All right, so you're ready to really like dive deep into AI and, build that solid understanding of the fundamentals. And you've chosen excerpts from the book AI Foundations of Computational Agents, the third edition.
hmm
That's a fantastic pick, actually. I've heard even, some of the biggest names in AI recommend that one.
It's a classic. Yeah, it's a classic for a reason. You know what I love about this book? It manages to bridge that gap, between like that cutting edge AI, like the generative AI everyone's like talking about these days, and the more traditional, methods. And it does it all within this like really insightful agent framework, which I really like.
Okay, so let's unpack that agent framework then. Like, what does that actually, mean? What exactly is an AI agent? I mean, it sounds a bit like sci-fi, to be honest.
Yeah, I can see why you'd say that. But,
Yeah.
at its core, an AI agent is simply a system that can perceive its surroundings and then take actions to achieve its goals, right? It's like a super smart problem solver that's constantly learning and adapting.
So less about taking over the world and more about like helping us with like everyday tasks. So give me some examples. Like what can these agents actually do?
Exactly. Yeah. The book uses some really relatable examples. Imagine an agent that bids on those online auctions for you, so you never go over budget. Or, picture this, an agent that like plans your entire vacation, booking flights, hotels, rental cars, all based on your preferences. Could even handle like unexpected situations, like flight cancellations and things like that.
Okay, that vacation planning agent sounds like a dream come true, especially that part about handling cancellations because, no one likes dealing with that. But what about like something even more, advanced? Like how far can we push this agent concept?
Well, let's push the concept a bit further then. So imagine a smart home that's like a futuristic butler, right? It manages your whole house, adjusting the lights, ordering groceries, and even like tutors your kids when they need help with their homework.
Whoa, 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 hold on. Tutoring. That's a pretty big responsibility to hand over to AI. What makes an agent like that actually work? Like how does it actually, function?
That's where things get really, really fascinating. So the book lays out these like key dimensions of complexity that you really need to consider when designing agents, right? And each one kind of adds another layer of sophistication to the system.
Okay, give me the rundown then. What are these dimensions? Like where do we even begin?
Well, one of the first is representation. This is all about how the agent stores and uses knowledge, right? So for our smart home example, it might use like a system of features and relations to describe things like light switches, right? Is the switch up or down? Is it connected to a specific light? Things like that.
So it's like giving the AI like a blueprint of the house and how everything works together.
Exactly, exactly. Then you have computational limits. So in an ideal world, an agent could make perfectly rational decisions instantly. But in the real world, there are constraints. Like our tutoring agent, it needs to find a good learning task for a student quickly, before they get bored or distracted.
Time pressure, that's something even AI can't escape.
Right. And then there's uncertainty, which is a huge factor in pretty much like everything. So our travel agent needs to handle those unexpected flight cancellations, right? And the tutoring agent needs to adapt to how a student is responding to a lesson. Sometimes you just don't know how things will land.
So it's about building in the ability to handle like curveballs. That makes sense. Okay, what's next?
Well, then you got preference. And this is all about the agent's goals. Like, are they simple? Are they super complex? A basic trading agent that might just want the lowest price. But something like a medical AI that has to weigh like tons of factors, right? Like patient suffering, treatment
Wow.
costs, all these things when it's making its decisions.
Makes sense. Like how a doctor has to balance, all sorts of considerations when making a diagnosis. So are those all the dimensions then? Is that everything we need to think about?
Not quite, not quite. We also have the number of agents, right? So is it working alone? Is it competing against other agents? Or is it like collaborating as part of a team? Think about self-driving cars, right?
Yeah.
They need to work together smoothly to avoid accidents and, optimize traffic flow.
AI teamwork, huh? I love that. Okay. So is there anything else we need to think about? Anything we're missing?
Last but not least, we got interactivity. So does the agent make decisions offline, at its own pace, or does it need to react in real time? That trading agent we talked about earlier that needs to be super quick on its feet, right? Adapting to that constantly changing stock market.
Yeah, speed is everything in that kind of environment. You snooze, you lose, as they say. Okay, so those are the like key dimensions then. It sounds like there's a lot that goes into designing these AI agents.
Absolutely. But the results can be like incredible. Remember that idea of a smart home that can like tutor your kids? Well, that brings us to one of the most talked about areas of AI today, which are neural networks.
I was wondering, when we get to those, I know that listeners specifically highlighted chapter 8 of the book, which is all about neural networks, so they're definitely interested.
Well, neural networks have been behind some of the most impressive AI breakthroughs in recent years, and they're especially good at, tasks that involve learning from vast amounts of data.
So let's dive in then. Like, what are some of those, like, key concepts we need to understand when it comes to neural networks? Like, what are the basics?
One of the, I guess, most fundamental is word embeddings. It's basically a way of turning words into numerical vectors that capture their meaning and, how they relate to each other. It's kind of like giving AI a way to understand
So
language.
does that mean AI can actually understand language in the same way that, like, we do? Or is it more of like a mathematical trick?
That's that's a great question actually, and it's one that researchers are still debating. But what we do know is that word embeddings allow AI to do some, pretty incredible things with language, like translating languages and analyzing sentiment in text.
That's pretty impressive. So what about, like, other types of neural networks then? Are there, like, different flavors we need to know about?
Well, if we're talking about processing text, we got to talk about recurrent neural networks, or RNNs for short. These are specifically designed to handle sequential data, like, the words in a sentence. And then there are LSTMs, which are a special type of RNN that are really, really good at remembering information over long sequences of text.
Okay, so LSTMs are like the AI equivalent of a really good memory then.
Yeah, think about how we follow a story, right?
Yeah.
We remember what happened earlier to make sense of what's happening now. LSTMs give AI that same ability, which is why they've been so revolutionary for things like language translation and, speech recognition.
Yeah.
They can even generate text that sounds like it was written by a human.
That's wild. AI writing poetry, I never thought I'd see the day. But how do these networks, like, actually understand context? Like, if I say bank, how does AI know if I'm talking about a riverbank or a financial institution?
That's where attention and transformers come in. These mechanisms allow networks to focus on specific parts of the input, which is, super crucial for understanding the meaning of a word in its context. So if the surrounding words are like money and account, the AI knows you're probably talking about, a financial institution.
So it's like AI is learning to read between the lines then.
Exactly. Exactly. And this brings us to the big leagues, which are the large language models. These are the powerhouses of AI, right? Trained on just massive amounts of data. And they're capable of some truly, truly remarkable feats. They can write different kinds of creative content like poems, codes, scripts, musical pieces, email letters, etc. They can answer your questions in an informative way, even. But as these models become more powerful, they also raise some important questions about, ethics and bias.
That makes sense. Like, the more powerful AI gets, the more important it is to think about, the potential downsides.
Absolutely. And it's not just about language, right? Neural networks are also incredibly good at processing visual information. That's where convolutional neural networks, or CNNs, come in. They use these things called kernels to detect patterns in images, making them ideal for tasks like image recognition and, object detection.
So CNNs are like the AI equivalent of, like, our visual system then. They can, like, see and understand images.
That's a good way to think about it. The the reason your phone can recognize your face or your car can detect pedestrians, like that's all CNNs at work.
Okay, so we've covered word embeddings, RNNs, LSTMs, attention transformers, large language models, and CNNs. Wow, that's a lot. It sounds like neural networks are doing some, truly amazing things these days.
They really are, but it's important to remember that neural networks are just one piece of the like AI puzzle, right? There's a whole other world of AI that relies on logic and symbolic reasoning.
I was going to ask about that, actually. The listener also included excerpts from chapters 15 and 16 of the book, which seems to be all about, logic and knowledge representation.
Right, right. And these approaches might feel, very different from neural networks, but they're equally important for building truly, truly intelligent systems.
Well, let's dive into that world then. Like, what's the basic idea behind, logical reasoning in AI? Like, how does that even work?
In a nutshell, it's about representing knowledge using symbols and relations, almost like building a logical puzzle. And the book uses this really vivid example of an electrical circuit.
Okay, I'm intrigued. How does AI use logic to, like, understand a circuit?
It starts by defining what are called predicates, which are basically like logical building blocks, things like light, lit, live, connected to, these describe the parts of the circuit and their states.
So it's like giving the AI a vocabulary to talk about the circuit.
Exactly. Exactly. Then you have definite clauses. And those are rules that capture, how things actually work. So, for example, a rule might state a light is lit if the switch is up and the circuit breaker is okay.
That's a pretty intuitive way to represent like the relationship between the switch and the circuit breaker and the light.
Right. Right. And what's really cool is that this approach lets the system answer like questions like, is the light lit?
Hmm.
It can even figure out what might happen if you change something, like flipping the switch or tripping the circuit breaker.
So it's like the AI can like simulate what would happen in the real world just by, thinking about it logically. That's pretty amazing.
It is, it is.
Yeah.
And unlike some neural networks, which can feel like, black boxes with logical reasoning, you can actually see the steps the AI takes to reach its conclusions. It's all very transparent.
That's a good point. Transparency is definitely important when we're talking about, AI making decisions that could, actually affect our lives.
Yeah.
So are these logical approaches like used in any like real world applications? Like, is this just, theoretical stuff or is this actually being used out there?
Oh, absolutely. Absolutely. They're used in all sorts of areas from, robotics and planning to expert systems and knowledge management. And while they might not be as like flashy as neural networks, they're often the best choice for tasks that require, clear explainable reasoning.
This is also fascinating. It sounds like AI has come a long way since, those early days of like checkers playing program.
It really has. It really has. And to, appreciate just how far we've come, let's take a quick detour through the like history of AI. So the book highlights some pretty, pivotal moments that help us understand how we got to like where we are today.
Okay, I'm ready for a history lesson. So
Ugh.
where do we begin? Like, take me back to the early days of AI.
Well, some of the like earliest applications of computers were actually AI programs, believe it or not. So back in the 1950s, researchers were already exploring the potential of AI to solve problems that had traditionally been considered, the domain of human intelligence.
Look, what kind of problems? Give me some examples.
One of the like early challenges was game playing. So in 1952, Arthur Samuel created a Checkers program that could learn from its own experience. Just a few years later, his program was good enough to beat the Connecticut State Checkers champion.
Wow, that's impressive. So AI was already making like waves back in the 50s.
Absolutely.
Yeah.
Absolutely. And around the same time, Howing created a program that proved hundreds of like complex logic theorems from Principia Mathematica, which is this, groundbreaking work in mathematics and logic.
So AI was like tackling both games and logic then. What else was happening in those early days?
Another big area of research was neural networks. Inspired by the structure of, the human brain, researchers were trying to build artificial neural networks that could like learn from data.
Now, the idea of neural networks goes like way back.
It does. It does. One of the like early breakthroughs was Frank Rosenblatt's perceptron in 1958. But research in neural networks, faced some setbacks in the years that followed.
What kind of setbacks? Like what happened?
Well, there were, limitations in the types of problems that these early networks could solve, and some researchers argued that they were like fundamentally flawed. As a result, funding for neural network research like dried up, and the field went through what's now known as the AI winter.
Oh wow. So what brought neural networks back to life then? Like how did they come back from that?
The resurgence of neural networks can be attributed to like a number of factors. New algorithms and architectures were developed, and the increasing availability of computing power made it possible to train larger and more, complex networks.
It sounds like a perfect storm of advancements then.
It was, and the real turning point came in 2012 when Alex Krzyzewski and his colleagues achieved like groundbreaking results on the ImageNet dataset.
ImageNet. What's that?
ImageNet is a like massive data set of, labeled images. Krzyzewski's team used a deep learning model, which is, a type of neural network with many layers, to classify images with an accuracy that, far surpassed any previous approach.
So ImageNet was like a proving ground for deep learning then.
Exactly, exactly. It showed the world what deep learning was capable of, and it, sparked this renewed interest in neural networks.
It's amazing how one data set can have such a like profound impact on, a whole field.
It really is. It really is. And since then, we've seen this explosion of research in deep learning leading to like breakthroughs in areas like, natural language processing, computer vision, and robotics.
Okay, so neural networks are like that's a big way. But what about those logical approaches we talked about earlier? Like where do they fit in?
That's a great question. So while neural networks have taken, center stage in recent years, logical reasoning remains, a crucial part of AI. And in fact, there's a growing movement towards combining the strengths of both approaches.
Combining like neural networks and logic. Like how does that even work?
Yeah, researchers are exploring ways to like integrate symbolic reasoning into, neural networks, allowing them to learn from data while also being able to, reason logically.
So it's about creating AI systems that can like think both intuitively and rationally then.
Yeah, exactly. Exactly. And this hybrid approach holds a lot of like promise for building truly intelligent systems.
This is all so exciting. It sounds like the future of AI is like wide open. There's so many different like paths to explore.
It really is. And, understanding the history of AI from those early like checkers programs to the resurgence of neural networks gives us a better appreciation for the incredible like progress that's been made and the challenges that still lie ahead.
All right, so we've covered a lot of ground here from the basic definition of, an AI agent to the history of AI and the like different approaches being used today.
We have. And as we, delve deeper into the world of AI, we'll see how these concepts play out in like real world applications. We'll explore different like types of agents like that trading agent and the smart home agent we discussed earlier. And we'll see how the choice of approach, whether it's, neural networks, logic, or a hybrid can have like a profound impact on an agent's, capabilities.
Sounds great. I'm looking forward to learning more about those specific types of agents and seeing how all these concepts kind of like come together in practice.
Me too. Me too. Let's continue our exploration.
All right, so we've talked about the like building blocks of AI agents. We've taken that like trip through the history of AI. Now, let's shift gears a little bit and look at some real-world examples of these agents in action.
That's a great idea, yeah. Seeing these concepts applied in different contexts will really help solidify, your understanding. So, where should we start? What do you want to talk about first?
Well, we talked about trading agents a little bit earlier, right? And I'm curious to like learn more about how those actually work, like what's going on under the hood.
Trading agents, yeah, they're a fascinating example of how AI can be used to, automate those complex tasks in these really dynamic environments. Essentially, these agents interact with information environments like, financial markets or, online marketplaces to buy or sell, goods and services on behalf of a user.
So they're like AI stockbrokers or like personal shoppers.
Exactly. A simple trading agent might handle something like, proxy bidding on an auction site. So it would like automatically place bids up to your, predetermined limit, saving you the hassle of constantly monitoring the auction.
That sounds pretty convenient. What about more complex trading agents, though? Like, what are those capable of?
Well, imagine an agent that like manages your entire investment portfolio, right? It analyzes market trends, assesses your risk tolerance, and then like makes buy and sell decisions to optimize your returns.
Wow, that's a lot of responsibility to hand over. Are these agents really like sophisticated enough to handle something like that?
They are, and they're getting more and more advanced all the time. These agents leverage like a range of techniques, including machine learning and predictive modeling, to make informed decisions in real time.
Real-time decision making, huh? That must be like crucial in that fast-paced world of, trading. What are some of the challenges these agents face, though? Like, what are some of the things that can trip them up?
One of the biggest challenges is dealing with, the inherent uncertainty of the markets, right? No matter how much data you analyze, there's always an element of like unpredictability. So a good trading agent needs to be able to like adapt to changing conditions and make those decisions under pressure.
Sounds like a high-stress job, even for an AI.
It is. But the
Hmm.
potential rewards are, significant. A well-designed trading agent can really help individuals and organizations, make smarter financial decisions and, maximize their profits.
Okay. So trading agents are all about navigating that complex world of, finance. What about something a little bit closer to home, though? We talked about smart homes earlier. Let's dive into those a little bit more.
Smart homes, yeah. Those are a prime example of how AI is, transforming our daily lives. Remember the concept of an agent that, perceives its environment and then takes actions to achieve its goals. That's exactly what a smart home agent does.
So it's like the home itself becomes an intelligent agent.
Precisely, yeah. It interacts with that, physical environment, managing various systems and appliances to create a comfortable and, efficient living space.
I'm picturing a home that, adjusts the lights, the temperature, even the music, all like based on my preferences. Is that the kind of thing we're talking about here?
Yeah, that's just the beginning. A truly intelligent smart home can do so much more than that. It can actually like learn your habits and preferences, anticipating your needs before you even have to ask.
So it's not just about like reacting to commands. It's about like being proactive and,
Yeah.
and personalized.
Exactly.
Yeah.
Exactly. So imagine a smart home that knows your work schedule and preheats the oven, just before you get home, or it recognizes that, you're feeling stressed and it dims the lights and plays like some calming music.
That sounds amazing.
Yeah.
But how does like a smart home agent actually know all of these things about me? Like how does it gather that information?
Well, it all comes down to data. So these agents are constantly collecting data from various sensors throughout the house, right? They monitor things like, temperature, light levels, motion, even your like voice commands.
So the house is like basically learning about me by observing my behavior.
Exactly. Yeah.
Yeah.
And the more data it collects, the more personalized and, responsive it can become.
That's pretty impressive, but it also raises some concerns about, privacy. Are there any safeguards in place to like protect our personal data?
That's a crucial question. As AI becomes more integrated into our lives, it's essential to consider the, ethical implications and ensure that privacy is protected.
Absolutely. Okay. So we've talked about trading agents, smart home agents. What other types of agents are out there like making an impact? What else can these things do?
Well, remember that smart home with like the tutoring feature that we discussed earlier? That brings us to another like really fascinating type of agent, the tutoring agent.
Okay. So we're talking about AI that can like teach. That sounds like a huge challenge.
It is, but the potential benefits are, enormous. Imagine an AI that can like personalize the learning experience for each student, providing, tailored instruction and feedback.
So it's like having a personal tutor for every student.
Exactly, exactly. And the key to designing effective tutoring agents, lies in understanding those dimensions of complexity that we discussed earlier.
Right, like representation, computational limits, uncertainty, preference, number of agents, and interactivity. How do those like play out in the context of,
Yeah.
a tutoring agent? How do those things affect how they're built and how they work?
Well, representation, that's crucial. A tutoring agent needs to have like a sophisticated understanding of the, student's knowledge, including their strengths, their weaknesses, and their learning style.
So it's not just about like tracking grades, it's about understanding how each, student learns best.
Exactly. Yeah. And computational limits are important too. A tutoring agent can't spend like hours searching for the perfect learning resource for each student. It needs to be able to make those decisions, quickly and efficiently.
Yeah, efficiency is key, especially in an educational setting where, time is limited. What about uncertainty though? Like how does a tutoring agent handle that? How does it deal with like the unexpected?
Well, unlike a traditional textbook, which, presents information in a fixed sequence, a tutoring agent needs to be able to like adapt to the student's responses and adjust its approach accordingly.
So it's about being like flexible and responsive, just like a human tutor would be.
Exactly, exactly. And preference is key too. A tutoring agent needs to understand, the student's goals and their motivations to keep them, engaged and on track.
It's like tailoring that learning journey to fit, yeah, the individual student's like destination. But are these tutoring agents like actually being used in classrooms today? Like is this something that's happening now?
They are, yeah. And they're becoming, increasingly sophisticated. We're seeing a growing number of, AI-powered tutoring systems that can provide personalized instruction, feedback, and even like motivational support.
That's pretty amazing. It sounds like AI has the potential to like really revolutionize education.
It really does. And as AI continues to evolve, we can expect to see even more, innovative applications of these agents in, various domains.
So we've talked about trading agents, smart home agents, and tutoring agents. Is there like a common thread that runs through all these examples? Like, what makes them all agents in the AI sense?
The common thread is that they all exhibit, a certain level of autonomy, right? They're able to like perceive their environment, make decisions, and take actions to achieve their goals, all without, constant human intervention.
That's a good point. It's not just about automating tasks, you know.
Mhm.
It's about creating systems that can actually operate, independently and intelligently.
Exactly. And that's what makes AI agents so powerful and so fascinating.
Well, I'm definitely fascinated by all of this. It's incredible to see how AI is being used to solve, real world problems in such like diverse areas. But I'm also curious to like dig a little bit deeper into the specific approaches used to build these agents. We talked about neural networks and logical reasoning. How do those actually come into play when designing, these different types of agents?
Yeah, that's a great segue. The choice of approach often depends on, the specific challenges that the agent needs to overcome. So let's revisit those approaches and see how they're applied in the context of, these real world agents.
All right, so we've, seen how these AI agents are being used in finance, in our homes, and even in education. Now, let's get back to those different AI approaches. We've talked about neural networks and logical reasoning, but how do those, actually play out when building these real-world agents? Like, how do those things actually get implemented?
Well, it's not always a simple either situation. Sometimes the best approach is to like combine the strengths of both neural networks and logical reasoning. It's about bringing those two worlds together.
Okay, so it's like a toolbox where you choose the right tool or, combination of tools for the job. Can you give me some examples? Like, how does that work in practice?
Absolutely. Let's take that, trading agent we talked about. It needs to analyze massive amounts of data to identify patterns and make predictions. That's where neural networks, really, really shine. They can like sift through mountains of data and find those subtle correlations that humans might miss.
So the neural network is like the trading agent's research department, constantly crunching numbers and looking for insights.
Yeah.
What about logical reasoning then? Where does that fit into this whole picture?
Well, once the neural network has identified some potential, trading opportunities, the agent needs to make a decision. Should it buy, should it sell, or should it hold? That's where logical reasoning comes in. The agent can use, rules and constraints to evaluate the risks and the potential rewards of each option.
So it's like the neural network provides the raw data, and then the logical reasoning component acts as the decision maker, weighing the pros and cons.
Exactly. Yeah. It's about combining that intuitive pattern recognition ability of neural networks with that clear structured reasoning of logic-based systems.
That makes sense. What about like smart home agents? How are neural networks and logical reasoning used there? Like how do they play a role in that kind of setting?
Well, imagine a smart home agent that uses facial recognition to identify different members of the household. That's powered by a neural network that's been trained on, images of faces.
So the neural network is like the smart home's eyes, allowing it to like recognize people.
Right. And once the agent has identified you, it can then use, logical rules to adjust the home settings based on, your preferences. For example, if it knows you prefer a cooler temperature, it'll automatically adjust the thermostat when you enter the room.
Okay. So it's like a personalized welcome based on my unique, profile.
Yeah.
That's pretty cool. But what about something like that tutoring agent we talked about? That seems like, teaching requires like a lot of flexibility and adaptability. Can neural networks and logical reasoning really handle that?
They can. They can. And this is where, things get really, really interesting. A tutoring agent might use a neural network to, analyze a student's writing and identify areas where they're struggling, with grammar or syntax.
So the neural network acts as a sort of like automated proofreader then. What happens next? Like how does the logical reasoning come in?
Well, once the agent has identified those areas, it can use, logical rules to provide feedback and suggest, resources for improvement. It might even tailor its approach based on the student's, learning style, offering different explanations or exercises, depending on their needs.
That's a pretty sophisticated level of personalization. It sounds like these tutoring agents have the potential to really, really make a difference in education.
They do, they do. And this is just one example of how AI is being used to, enhance, human capabilities.
Well, I think you've done a great job of explaining how these, different AI approaches are being used to build real-world agents. It's clear that AI is already having like a huge impact on our lives, and it's only going to become more, pervasive in the years to come.
I agree. I agree. And, as we move forward, it's crucial that we understand the underlying principles of AI so that we can, engage with these technologies, thoughtfully and responsibly.
Absolutely. So for our listener who's, diving deep into the world of AI, what's the key takeaway from all of this? Like what do they really need to remember?
The key takeaway is that AI is a multifaceted field with a rich history and a really really bright future. It's about building intelligent agents that can perceive, reason, learn, and act. And it's driven by a variety of approaches from neural networks to logical reasoning and everything in between.
That's a great way to sum it up. So as you encounter AI in your, daily life, remember that it's not just about the technology itself. It's also about, the human ingenuity behind it and the choices we make about how to use it.
Well said. Well said. The future of AI is in our hands, and it's up to us to shape it in a way that benefits, all of humanity.
And with that thought-provoking note, we'll wrap up our deep dive into the fascinating world of AI. Thanks for joining us.